So hi guys, in this video we're going to be implementing stacks using arrays. So let's see. I've written some piece of code here. I'm going to explain everything and we're going to build the push and pop functions on spot. So let's see. So at the beginning the hash include stuff, you know about it. So what does this line mean? Hash define max space 5. It just means that wherever I write max, it's going to be substituted by 5. That's all. There's not a variable, just a label for this 5. That's all. So I use this because of the, like the easiness to change the whole thing. If I want to change everything to 100, I don't have to go everywhere and change. I can just change here, right? Like this. That's why. Okay, so let's go to the next line. What is this thing? Type def struct. If you know about structures, you can clearly see that this is a model for a single stack. Every stack has one array for all the values and one variable to keep track of the top. And every time I create a stack object, it's gonna have one array and one top associated to it. So every object is a stack. So let's carry on. So stack init this function. So what does this function do? It's going to return a stack variable, so that much we know. So inside this init, what I'm doing is that I'm creating a stack object. I'm initiating the top variable with 0, the top variable of this stack as 0, and then I'm returning it. Okay, for attaining full closure in this function, you can understand only when you see where I call it. So I created a stack, and then I did s1 equals init. So when I do s1 equals init, this init goes and creates a stack variable and then it initiates the top with 0, which means it's an empty stack, and then returns the empty stack. So it's just initiating an array, the initial values for a stack. The comment says everything, yeah? Okay, so display is also easy. We're just printing from top to bottom, that's all. Okay, let's carry on. So I'm creating push function. Okay, let's carry on. So what does this push function do? Before writing any function, first we should create its prototype. A prototype is this line, yeah, the first line. What it's going to return, what is its name, and what is it going to accept. In this case it's not accepting anything, but this is going to accept something. So the accepting part is pretty easy to figure out. Just ask a few questions. So what are the questions? So I'm going to push into a stack. Into what stack? Yeah, into this stack. So I'm going to pass a stack from here. So push into the passed stack. Now what number should I push? Push this number. That's all. So the accepting stuff is over. Now what is the return data type for this? For that, it's a little bit tricky. First you have to plan how are you going to call this function. If you see the place of calling, you can easily find out what it's going to return. Well, there's a lot of ways to write this function. I'm just saying one way. You can adapt to any other way if you understand this way. So let's see. I planned, so I've just commented this as of now, or it's going to show an error. The red line is pretty annoying, So yeah, so just commented this, but you can see, I guess, I've planned to call the push function just like how I call the init function, which means the push function should also return a stack. You understand? Because you can only assign a stack to a stack, right? Yeah. So hope you understood. If you didn't, put up in the comments. Cool. So let's just start with the push function. At the beginning, as I said in the previous video, I'm going to check for overflow because it's pushing, right? If the array is already over, wait, let me erase this thing. Spoiler alert, guys, spoiler alert. Okay, so first I have to check whether the stack is full. Didn't delete all the spoilers, I guess. There's nothing as of now. Okay, so this is also nothing. Okay, let's carry on. Sorry for that. Okay, first I'm going to check whether the stack is full. If the top is already 4, that means the stack is full, then there's no room for pushing, so don't do any changes to the stack, just return as it is. So instead of 4, I'm putting max minus 1, yeah, because max is 5. Cool. So what am I going to do if it's overflow? First, the person has to know that it's overflow, right? Because everyone won't see the code because, you know, like that. Okay, so print overflow, and then I'm not doing any changes to stack, I'm just returning it as it is. So this means that, see, I'm doing s1 equals push of s1 comma the data. So I'm just passing s1, right? So the data inside s1 is in s also, and I'm not making any changes, I'm just returning like that. So this is just like assigning s1 to s1 itself, right? So basically it's making no changes. Okay, so if it's not overflow, that means there is room. Now let's uncomment the first call. So s1 equals push s1 comma 5. So I'm going to push 5 to this empty stack. Now I did init, so the top is 0 at the first default. So I'm passing, so this s is what is here, okay? This s and this s is basically this, okay? So s dot top becomes 0 now because I'm passing s1 and s1's top is 0. Now data, I'm passing 5 for it, so data will be assigned with 5. Okay, so remember this s and data are local variables for this function. Yeah, so it's not going to reflect anywhere. So these two variables are going to get killed after the function is over. So that's why I'm returning, you see. Okay. Now, as I said in the previous video, the order is first I'm going to increase the top. So s dot top plus plus. So the top is increased. Now the second thing is I'm going to insert the data into the top position of the array. So basically s dot vals of s dot top, I'm going to assign that with data. So you'll see s dot vals, I'm just going to write what I said just now. S dot top, the increased top was data. Now s dot vals of 1 is this place and data is 5, so this place is going to be written by 5. You see, we pushed it and we also kept track of the top perfectly. Now the only remaining task is just to return the modified stack. Now this modified stack, the values inside this modified stack, sorry, I just shook the computer. So okay, so the value inside the modified stack is returned here, and that is assigned to s1. So we actually pushed into s1. Okay, so let me uncomment all the other stuff. Cool. So now I'm calling s1 comma 7. So now the top in s1 is 1. So the top in s is also going to become 1, and the data is 7 this time. Yeah, hope you get it. Now it's going to check whether s dot top is max minus 1, which is 4. So max is 5, it's saying here like clearly. So it's not 4, it's 1. So this will bypass, and then now s dot top plus plus, this is going to become 2. Oh shit. This is going to become 2, and now I'm inserting the data in the top index. So s dot vals of s dot top is data, which is 7. Cool. And I'm returning, and then so pushed. So this happens 2 more times. I'm going to fast forward for the next 2 iterations. Anyways, I'm going to preserve the order. So it's 2, next is 10. You see the calls, you follow, and then I'm increasing, and then I'm inserting. The next call is 15, so data becomes 15. I'm increasing the top and then inserting, which is pushing. Okay, now let's go through the last one, because you can clearly see that it's an overflow because the stack is full, right? So it's going to go inside and it's going to check whether s dot top is max minus 1, and max is 5, so max minus 1 is 4, and s dot top is 4. So yeah, it is an overflow, so it's going to come inside, and printf is going to print overflow, and then it's going to return s as it is with not making any changes. And we also know that the return statement ends the function, so the function is over, I'm sorry, and then these statements are bypassed. So that's how push works. I hope you understood. So let's go to pop. Okay, you'll understand these things in a while. So I'm planning to call pop the same way like I call init and push. So it's going to return a stack. Cool. Pop. We are working on the prototype now, if you didn't realize. So pop from what stack? I'm going to pop from this stack. Now there's one more parameter which is kind of tricky. The thing is, if I just pop from this stack and I don't know what number I popped, then the whole purpose of a stack is like destroyed. So what I'm doing is I'm creating a pointer. Okay, if I could spell data properly. Okay, so yeah, I'm creating a pointer here and I'm passing the address of an integer variable. Okay, let me just uncomment these lines. Okay, don't know what happened. Yep, so see, I created an integer variable here, initiate that with -1 because it cannot be empty, and then I'm calling pop with s1 as usual, and then the address of this d. So whatever changes I make to this pointer is going to reflect here if you know about pointers. So data is going to store the address of this d. Get it? And I'm going to modify star data, so the value inside the address is going to be modified, which is going to reflect in d, and I'm printing d. You see? So it's pretty clear now. Okay, let's carry on. Now I'm going to check for underflow. If s.top equal to 0. If it's 0, then there's only ground and you can't pop the ground. So I'm not going to make any changes, just like how I did in the previous function, push. So underflow, and then I'm just going to return s as it is. Cool. Now let's go to the main part. So as I said in the previous thing, we're not going to erase anything, we're just going to decrease top. But before decreasing top, I'm going to get the value I'm going to pop into the pointer. So what I'm doing is I'm modifying star data, which is the content in the address, to s.vals of top of s.top. I hope you can understand this, because see, so s.vals of s.top, we're going to pop the topmost stuff, right? So I'm taking the topmost value into the address, and then I'm doing this top minus. Now top just becomes 3. This place is going to be ignored from now on, and if I'm going to push some other number from now on, this place is going to get overwritten, like I said in the previous video. Now the only stuff that's remaining is return the stack, and that's how it's done. Now let me, oh my god, there's too much, actually too much of examples. let me just put slash in everywhere, because of indentation purposes. When we see the output, you know, that's going to be pretty annoying. So always have the practice of putting slash ins while writing codes, you know, to have all the outputs in separate lines. Yeah, here also underflow and overflow. Cool. So let's carry on. So, and it's going to print popped 15. Yeah, because I changed the address, right? If you remember. Okay, now I'm popping again, so this is going to become 2, and date and start data is going to become 10. Yeah, last time it would have become 15, I forgot to write. Okay, so start data is going to be 10, and it's going to print popped comma d, so which is going to print pop 10, and that's going to happen once more. This will be 7. Once more, this will be 5. Now I'm popping again. Wait a second. 1 2 3 4 and 5. So this is iteration. Yeah, I'm popping again, so it's going to pop, and it's checking whether s.top is 0. Is it? You tell me. It is 0, huh? Therefore these places are gonna get bypassed, because this return is gonna get executed and it's gonna complete the function, right? So printf underflow and a slash n. So it's going to print underflow, and it's not going to make any changes to the stack. It's just going to return the stack as it is. That's all, guys. We've pushed and we've popped. Cool. So now let's see the output. Yep. gcc brg.c. It's going to compile, and it's going to tell whether there are any errors or anything. I hope there is no errors. There are no errors. Oh my god, wait a second. What is that? 65. Oh, I wrote int twice, huh? Happens. So let's do it again. Oops, let's do it again. I hope I didn't write the CLS there. That'd be embarrassing, huh? Okay. So yeah, gcc prg.c. And it's going to say there are no errors now. Yep, no errors. Now there's one more stuff to do. See, and then finally the output is gonna it's printing overflow first because I didn't clear it. I don't know what happened. Oh yeah, I get it. It'll print overflow only when it's overflow, right? So you know, this is not an overflow, this is not an overflow, this is not an overflow, this also is not an overflow, this is an overflow. So it's printing overflow only once. And pop 15, pop 10, pretty cool, right? Pop 7, pop 5, and underflow pop 5 because I'm not even modifying, right? So yeah, that's how it works. I hope you understand. If you don't understand, please put up in the comments and I'll answer it as soon as I can. Thank you.